Hi, it's Mrs. Moret with help on today's assignment, the Unit 4, Lesson 4 problems. So number 1, a bacteria population is tripling every hour. By what factor does the population change in half an hour? So if it's tripling every hour, then in half an hour it would be 3 to the 1 half. And 3 to the 1 half can be represented also as the square root of 3. That would just be dividing it by 2, but with exponential, we're dividing the exponent, not the factor, so not B. This would be the cubed root of 2, so not C. And then this would be 3 to the second, so that would be like in 2 hours, not in a half an hour, so not E. All right, number 2, a medication has a half-life of 4 hours. So it takes 4 hours for half the medication to be present after it enters the bloodstream. A nurse administers a dose of 225 milligrams to a patient at noon. Write an expression to represent the amount of medication in milligrams in the patient's body at 1 p.m. on the same day and then at 7 p.m. on the same day. Okay, so it takes 4 hours. It's a 4-hour half-life. It was given 225 milligrams at noon. So at 1 p.m., that's just 1 hour later, the initial amount, 225, and then half will be present in 4 hours. So 1 hour later will just be 1 to the fourth, or sorry, 1 over 4. So the exponent 1 over 4. So 225 times 1 half to the 1/4. And then at 7 p.m. on the same day. So 7 p.m. is 7 hours past noon. So we would just say 225 times 1 half to the 7/4. Next, the expression 225 times 1 half to the 5 halves represents the amount of medicine in the body sometime after it is administered. What is that time? Okay, and so I'm going to say, well, 5 halves would be the same thing as 10/4, right? And so it would be 10 hours afternoon, which is 10 p.m. Okay, number 3. The number of employees in a company has been growing exponentially by 10% each year. By what factor does the number of employees change each month, every 3 months, and every 20 months? So we have a little bit of back work that we need to do is we need to talk about growing exponentially by 10%. Then what's the factor even just in the year? So remember, you do the full 100% plus the 10% growth and then divide it by 100 to make it a decimal. So in a year, the factor is 1.1. So each month, well, there's 12 months in a year. So it would be 1.1 to the 1/12. That would be each month. And then every 3 months, I could say 1.1 to the 3/12, or reduce that fraction to 1/4. You could also say 1.1 to the 1/4. So it happened 4 times in a year, every 3 months, and then every 20 months. So same thing, only we're going to have a larger fraction. So 1.1 to the 20/12. And you could certainly reduce that. 20/12 is equal to, let's see, divide by 4, 5/3. So it could be 1.1 to the 5/3. Any of those. Okay. For number 4, we have a graph. It shows the value of a truck, which is decreasing exponentially since its purchase. The 2 points on the graph show the truck's initial value and its value a decade afterwards. So that's a difference of 10 years, 1 decade. Express the car's value in dollars as a function of time, D, in decades since its purchase. Okay, so I know I'm going to use function notation. The initial value was 40,000. And then to figure out that factor. And the X one is just going to be D, and it represents decades. So from 0 to 1 decade, the value goes from 40,000 to 24,000. So I'm going to divide 24,000 by 40,000 to get that factor. Looks like it's 0.6. So since that's 0.6, that's what goes right here. And now write an expression to represent the car's value 4 years after its purchase. So 4 years is 4/10 of a decade or 2/5 of a decade. And so I'm going to use this idea and say, okay, so 40,000 times 0.6 to the 4/10 or 2/5. I'm going to use the reduced form of that fraction, 2/5. So 4 years later is 4/10 or 2/5 of a decade. And then for part C, by what factor is the value of the car changing each year? Show your reasoning. So in 1 year, this factor is equal to 0.6 to the 1/10, because again, 1/10 is how you would represent 1 year as part of a decade. So I could write 0.6 to the 1/10, and then I'm going to actually figure out what that is. About 0.95. So approximately 0.95 each year. Okay, by that factor each year. Okay, number 5, the value of stock increases by 8% each year. Explain why the stock value does not increase by 80% each decade. So if it increases by 8% each year, then again, we're going to think about, well, what is that as a factor? It's 100 plus 8 divided by 100. So that's 1.08. And so that would be the yearly factor. And so in a decade, it happens 10 times. So I'd say 1.08 to the 10th. 1.08 to the 10th is about 2.16. Okay. And so then that's actually going to be like a 216% increase in the decade. All right. So it's 1.08 to the 10th, not 8% times 10. All right. So we're working with exponents. And so with exponents, we're looking at repeated multiplication. Does the value increase by more or less than 80% each decade? Well, I actually calculated it. So 2.16 equals 216%. So definitely more. Oh, and then also, sorry. So also on that, I forgot to take off the 100. So this is like the percent of it, but that means it increases by 116%. Forgot to do that last little part. Okay, and moving on, number 6, decide if each statement is true or false. So 50 to the 1/2 means the square root of 50, so this one is false. The square root of 50 is like 7 point something. It is not 25. B, the square root of 30 is a solution to y squared equals 30. Yes, square rooting is how you would find that solution, so this one is true. C, 243 to the 1/3 is equivalent to the cubed root of 243. All right, so this is going to be the exponent and over the index, so the exponent over the index, so that is true. And then for D, the square root of 20 is a solution to m to the 4th equals 20. No, it would have to be the 4th root of 20 so that the exponent and the index match when you're solving, so this is false.